Hi everyone, welcome to Introduction to Two-Column Congruence Proofs. To complete a two-column congruence proofs, you have to draw two columns, one being statement column and one being the reasons column. You always write your givens first. You write your proof statement last, and the second step is going to be either to use vertical angles or reflexive property. Make sure to circle any keywords and write definitions in the reasons column. Let's take a look at an example of a two-column congruence proof. Here we have an example of a proof. Notice we have our givens. AD congruent to CB and AB congruent to CD. You write that first. The reason is that it is a given. Then you look at your proof statement and you write that last. Triangle ABD congruent to triangle CDB. The second statement you write is either going to be using the reflexive property or the vertical angles property. So what you should do now is you should mark up your diagram. So AD is congruent to CB and AB is congruent to CD. Notice that in order to prove the two triangles are congruent, we have BD being shared in both triangles. So therefore, BD is congruent to DB, uses the reflexive property. I have three pieces. I have a side, and another side. Therefore, I can prove the two triangles congruent by side, 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 congruent to side, side, side. That is a full and complete proof. Again, start with your givens, mark up your diagram, write your proof statement last, use either reflexive or vertical property second. And based on the diagram, determine what method you should be using. In this case, it was side, side, side. Let's look at another example. We have given angle B congruent to angle D, so let's mark up our diagram. B congruent to D, and BC congruent to DC. Write the given as your first statement, and the reason should be given. Write the proof statement last. Triangle ACB congruent to triangle ECD. Second, we have to look at our diagram and see if there's either vertical angles or reflexive property. Notice that there is an X, so there has to be vertical angles. Make sure you put a 1 and a 2 in your diagram. Angle 1 is congruent to angle 2. Vertical angles are congruent. Based on our diagram, I have an angle, a side, and an angle. So the method I have is angle, side, angle, congruent to angle, side, angle. That is a full and complete proof. Let's do this next proof. We have given angle N is congruent to angle S. And line L bisects TR at Q. I see the word bisect, so I'm going to circle it and make sure to use that as one of my reasons. So the first thing I'm going to do is write the givens in my first statement. And write given. Last, I'm going to put what I'm trying to prove. Triangle NQT is congruent to triangle SQR. Next, notice that I have an X here. So I have vertical angles. I'm going to put a 1 and a 2. angle 1 is congruent to angle 2, vertical angles are congruent. Next, I see the word bisect, so I'm going to write the definition of a bisector in my reasons. A bisector creates two congruent parts. Now remember, whatever comes second is what's being bisected. So TR is being bisected. TQ is going to be congruent to RQ. Now let's go back and figure out what method I'm using. I have an angle, and a side. Angle, angle, side. So angle, angle, side is congruent to angle, angle, side. There is my complete proof. We start out with the givens, we mark up the diagrams, and we write our given in our reasons for step 1. Step 2, we look for either vertical or reflexive property. Step 3, if there's any other definition that's given to you, you write it down. And then in step 4, we prove that two triangles are congruent, and you write the method that was used.